Filament winding is a technique primarily used to manufacture hollow, circular or prismatic parts such as pipes or tanks. When I am talking about prismatic, it means square shape. It is performed by winding continuous fiber toes into a rotating mandrel using a specialized winding machine. Filament wound parts are commonly used in aerospace, energy and consumer products industries. Continuous fiber toes are fed through a fiber delivery system to a filament winding machine, where they are wound into mandrel in a predetermined repeating geometric pattern. Toe location is guided by a fiber delivery head, which is attached to the movable carriage on the filament winding machine. The relative angle of the toe to the mandrel axis is called the winding angle and can be tailored to provide the strength, stiffness in the desired direction. When the sufficient layers of toes has been applied, the resulting laminate is cured on the mandrel. The overall size and shape of the finished part are determined by the mandrel shape and thickness of the laminate. The winding angles will determine the mechanical properties of composite parts such as strength, stiffness, weight, density of the laminate. The density of the laminate is the result of tension of the toes due to winding. Composite parts made through these methods generally have good strength to weight ratio. As far as the material options are concerned, we can wind glass fiber or carbon fiber through different type of resin. We have thermoset resins, we have epoxy, we have polyesters, we have vinyl ester and phenolic resins. As far as fibers are concerned, the fibers are used straight from creel and not woven or stitched into fabric form. However, tapes of any fabric, woven tapes can also be used to wind. That is called a tape winding. That is another topic. So there are basically two types of filament winding. One is called the wet winding and other one is the dry winding. In wet winding, the fibers are unwound from a roving and pass through a bath of resins mixture impregnation before it is wound on a mandrel of defined orientation. Pattern of the placement is controlled by the rate of rotation of mandrel and the feeding or metering mechanism, 3D network of fibers. As far as the advantages of filament winding is concerned, this is very fast and therefore economical way of laying material down. Resin content can be controlled by melting the resin into each fiber. If you are using a dry fibers, you can very effectively control the resin content. Fiber cost is minimized since there is no secondary process to convert fibers into fabric or something like that. The structural properties of laminate can be very good since straight fibers can be laid into a complex pattern. As far as the disadvantages are concerned, the process is limited to very convex shape of components such as we have some circular, some sort of cylinder or prismatic shapes. Cost for large components can be very high. As far as the aerospace components are concerned,